Alright, good morning once again. This will be the last video review lesson for you to prepare for this coming exam this Thursday and Friday. Alright, so let's review everything. So these are the different layers of the Earth. The core contains mostly iron, and as compared to the mantle, mantle contains only lighter matter. So the crust is only about 0 to 40 kilometers. It's the thinnest layer of the Earth. And the mantle is about 40 to 290 kilometers. And in the outer core, that's the liquid iron, which has a thickness of around 290 to 5,150 kilometers. And we have the solid inner core, the solid iron inner core, which is 5,150 to 6,370 kilometers. So as compared, you can see the cross-section of the layers. You can compare there the thickness of the different layers. You all know this already, the continental and oceanic. The oceanic is more denser as compared to continental. That is why when oceanic and continental converge or collide, it is the oceanic crust that will subduct or go through or will dive towards the mantle. Alright? So here it's the mantle. So let me explain that. Alright. So the composition, I will just let's just make review this one. The composition of the whole Earth and the Earth's crust. So when we say whole Earth, that includes the all layers, including the inner towards padulong sa crust. Majority of the components or majority of the elements that you can find in the Earth is iron. It comprises 33%, followed by oxygen, which is 30%, and silicon. Third, silicon, and any other elements. Alright, but when we say crust, in the crust, it is the oxygen that comprise most, or that is abundant, which is 46%, followed by silicon and any other elements, as you can see on the screen. Alright, so we have also, please also remember that, just as a trivia, it is the Earth which is the largest magnet. If you can find a magnet, from in your elementary class or from your previous grade, previous class, during your grade 7 up to grade 9, you can say that a magnet has two poles. It has north and south pole. So the same with the Earth, it has north and south poles. So meaning it is the Earth which is the biggest magnet, and we will try to explain later why this magnetic field, the Earth's magnetic field, can be one of the evidence or one of the best evidence that can explain the continental drift. Nganong ang kining magnetic field, isa siya sa mechanism or isa siya sa mga evidence na magamit nato para ma-explain nato ngano naga-separate ang Earth nato or naga-spread. So Earth's magnetic field is nearly a dipole. It has dalawa, north-south, with one pole near geographic north and the other near the geographic south pole. That is why we have the south and the north pole. The magnetic fields are produced by the motion of electrical charges. So therefore, the Earth contains charges and it continuously moves, and that creates magnetic fields, because without electrical charges, it is impossible to create or to generate magnetic fields. So magnetic field is due to motion of electrons in the magnet. So for example, if you have a bar magnet, the responsible particles or components that enables to create magnetic field are electrons. Meron tayong mga electrons, and the movement of electrons, it can create magnetic field. So electric charge on Earth requires, para magkaroon tayo ng electric charge sa Earth, it requires conducting core, which we have. The core, the inner core, it's metallic because it contains iron. And of course, the convection of core. Meron din convection of core or inside the Earth, diba? We have the convection current. And of course, the heat for convection derived from crystallization of molten core. So we have discussed this already. okay, the earth structure and the convection current, okay, the composition, what is this mantle, the density, okay, you all know that already. Okay, so in my previous lecture, okay, or video lecture, we have discussed or covered also the continental drift, the seafloor spreading, the evidence, okay, provided for by Wegener, okay, to convince us that there really is a drifting. Okay, we have also discussed this in our class, inside our class, the convection current. So this convection current facilitates the movement or the movement of the plates or the lithospheric plates. Okay, say for example, in that illustration, the convection current that is happening inside the mantle is the same as when you boil a water, okay, in a pot. Okay, the movement of the water as it boils, okay, moves upward. And after it cools down, it goes downward. Why? Because the hot material becomes what? Becomes less dense because it expands. And as it cools down, okay, pag magpunta na siya sa ibabaw, it will what? Contract. So it will become more dense, and eventually it will dive again towards or magsettle siya pa ilalim, and the process continues. The same with the convection current that is happening inside the mantle. Okay, meron tayong mga mechanisms na mangyayari diyan because we have the inner core, which is the source of heat because of the, what is that again? Because of the radioactive elements, and that supplies the heat of the inner core, and eventually it heats up, or it will create the convection current in the mantle because mantle is a liquid because of the molten materials. All right, and because of this convection current, it separates the plate. For example, we have there the plate A and plate B. We have the mid-oceanic ridge. As it separates, it creates mid-oceanic ridge, and as it separates, okay, the molten materials coming from the mantle will, okay, maglabas siya dyan sa ridge, and eventually it will pile up. That is why parang may ridge, or parang may anong tawag dyan? Parang may hump may tawag dyan. Okay, because of the piling up of materials. Okay, once maglabas siya, and it will eventually contact the water, it will cool down, and it eventually will solidify. All right, so okay, it's Wegener. Okay, just a quick story about Wegener. Okay, Wegener died at the age of 50. And having convinced no one, masyadong mahirap ang life ni Wegener before. Okay, because of his idea of continental drift. Okay. Although in his formative years, he was a robust and brave individual, he was, by all accounts, a peaceable man, and that made his service as a reserve lieutenant in the Queen Elizabeth Grenadier Guards. All right. So during the advance into Belgium, he was shot through the arm. Some 14 days after returning for duty, a bullet lodged in his neck, and he was declared unfit for active duty. Okay, sundalo pala ito si Wegener. He was then transferred to the Army Meteorological Unit. If we remind ourselves, the First World War took place between 1914 and 1918. It seems remarkable that somehow, during this period, he produced a major, literally earth-shattering book while on sick leave and while finishing the war in the Army Meteorological Unit. Wow! While during the World War, nabuo niya ang book niya. In 1919, Alfred Wegener, like his brother Kurt, became a departmental head of the German Marine Observatory in Hamburg, which is in Germany, and was also appointed as a lecturer at the newly founded University of Hamburg. Wow, galing. In 1924, he was appointed to the chair of Meteorology and Geophysics at the University of Graz, Austria, where he served until his death. Still very physically active as he approached 50 years old, he was to make 2 more expeditions to Greenland. He had planned a new Greenland expedition with G.P. Koch for 1928, but when Koch died, it meant that the expedition became an all-German affair. And Wegener obtained support from German Research Association in 1929. he made a brief visit to Greenland to find the most favorable route up to the inland ice cap from the west coast. The main expedition began in 1930 and they measured the thickness of inland ice at more than 1,800 meters, but the expedition ended in disaster. Wegener died in November 1930 while attempting to cross from a camp on the central ice cap to the base camp of the west coast. All right. So, as mentioned earlier, when he died in 1930, his theory drifted into limbo. It's so sad, no? You are very idealistic, but your ideas during that time is not are very criticized. It's been widely criticized by a lot of people. So, what was this theory and why the dissensions? Why was it referred it as preposterous, antiquated, a serious error, footloose, and even dangerous? So, very sad ang life ni Wegener. Okay, highly criticized siya. Parang hindi accepted yung theory niya on continental drift. But again, the continental drift, may pinaprovide siya na evidence. We have the feet of continents. Yung sinabi ko before, locations of the glaciers or glaciations. The fossils distribution, yung mga remains ng mga Glossopterus or any other animals na remains. And rock types and structural similarities like those, the structures, the patterns of the mountains in Canada, in UK. Okay? So we have these feet continents. Sabi nila, Pangea is true, meaning yung land mass before 200 million years ago is true because if you fit together these continents, okay, now, yung continents natin now, it will create one land, large mass. We call that Pangea because Pangea is theorized to be the original picture of the Earth before million years ago. We have also glaciation. If you fit this continents now, okay, yung continents natin today, and if we fit them together, it seems like the glaciation patterns or the glaciers or the glacial deposits seem to be located at some point or one location. Okay, that's another evidence. Okay, glaciations. And we have also the paleoclimate. So this is in addition to what I have mentioned in the earlier video. The paleoclimate seem to agree with the idea of continental drift because the climates of this, of this Pangea before seem to confirm that yung location or climate din natin because of the deposits, because of the remains, makikita natin na through yung Pangea. Okay? Because some of the organisms, plants or animals na buhay before because of the climate is makita pa rin natin sa this different type of climates because it drifted na or nag-change na yung location ng ating continents. Example, if Southern Pangea was at the South Pole in the Permian, Southern North America and Europe and North Africa should have been equatorial. So this matches the Permian distribution of tropical coals, tropical reefs, subtropical deserts, and subtropical evaporates. And also the fossil distributions, which we have tackled already, and the affinities, okay? So the rock types, the mountains, the patterns, the mineral deposits, okay, the same siya sa edges ng mga continents. That is why when we fit them together, it seems like the Pangea is really true because makikita natin na ang location ng mga deposits, mga rock types, rock ages are the same sa mga edges ng mga continents kung i-fit natin sila. Yes, it is true that geology is compelling, but what is the mechanism? That's the main question now. Totoo yung, yes, meron tayong mga evidence, pero the question is, what are the mechanisms? Bakit nag-move yung seafloor? But we have discussed that very well already. So, yung kay Wegener before, hindi niya ma-explain ng masyado or magaling masyado, ma-explain niya ng comprehensively because of the limited technologies before. Imagine, that was during World War, yung binuo niya na theory. And because of this limited technologies, okay, mahirap i-prove And yung evidence niya is very limited lang, more on ano lang, yung mga fossil remains, yung mention ko earlier, yun lang yung mga na-provide niya. So, ang major of the criticisms, most of the criticisms is that, what is the mechanism? Totoo, you have the evidence, you can provide evidence, but can you explain the mechanisms now? Bakit nagmo-move yung seafloor? Nagmo-move yung plates natin? Bakit merong continental drift? Bakit na-separate yung Pangea from being one large mass at naging separated into different continents na? That's the problem of Wegener before because he did not able to answer that. Hindi niya na-counter yung mga criticisms na binato sa kanya. Okay? So, that's the major criticisms. There was no mechanism. So, the Wegener's idea, okay, continents plowed through the ocean crust much like icebreakers cut through ice and invoke rotational forces, and neither of these ideas were tenable. So, na-rebut yung mga ideas ni Wegener. Very sad. And most of the thought before, yung mga nalalaman ng mga majority na tao, even the group of scientists, the prevailing thought or yung considered as fact, okay, is that ocean and continents were permanently fixed. Okay? So, yung mga knowledge ng mga people before, fixed lang talaga ang continents. Neither ay hindi siya mamumove, walang continental drift, ganon. Okay? That is why highly criticized si Wegener. And then, continental drift wasn't widely accepted until 1960s because of this paleomagnetic evidence of continental movement, the seafloor spreading, which we have well discussed already, and the plate tectonic theory. So we will tackle only this paleomagnetic evidence or the magnetic reversal evidence because we did not able to cover this in our class. Okay, again, Earth is like a magnet. Actually, in fact, it is the largest magnet. So magnetic field, it's the Earth's magnetic field results from convection of the liquid outer core around the solid inner core. The field acts like a giant bar magnet. It has north and south, which is true. The bar is tilted at 11 degrees from the rotational axis. The position of the bar gradually shifts. Earth's magnetic field is strong. It extends out into space. The north magnetic pole, okay, it points on Earth's surface at which magnetic field points vertically downward. Okay, sa North Pole. As you can see sa illustration, ang North Pole, okay, ang direction ng arrows niya or magnetic field points vertically downward. Okay, vertically downward. Check the illustration. While the North Pole points, okay, North Pole points where the axis of the rotational meets the Earth's surface. Okay. Alright. We'll skip this one. Okay. Alright. Magnetic reversals. Okay. This is the last evidence provided for by the scientists that will help us convince that indeed there is continental drift. So we call this one magnetic reversals. So what are these magnetic reversals all about? What is this magnetic reversals all about? It is a change in the magnetic polarity of the Earth's magnetic field. So we have magnetic polarity, di ba? We have the north and the south. And it is a fact established by the scientists that it reverses. The magnetic field of our Earth reverses abruptly through time with a time interval variable. So meaning, ang magnetic field natin, nag-reverse siya. Sometimes nag-shift yung field natin. Sometimes, maging positive, maging north and south yung direction niya. And the sad problem is that the reason or the causes of this magnetic reversals is not yet known. I don't know until today kung hindi ba siya known. But the causes, according to scientists, hindi siya known. But established siya, meron tayong mga evidence na nagre-reverse yung magnetic fields natin. So geologists have dated these reversals and used them as a tool to further subdivide geology. Mag-solidify siya because ang makontak niya ang water, and eventually it will piles up, magpile siya sa mid-ocean ridge. Okay. Kini mga molten materials, napo na siya mga magnetic elements. Okay, na siya mga magnetic elements or mga rocks. Okay. And kining mga magnetic elements, mag-behave siya or mag-arrange siya according sa polarity sa Earth nato. Di ba natay magnetic reversal or polarity? Di ba nakita to sa mga scientists nga naga-shift ang polarity sa Earth. So as the polarity sa Earth maga-shift, ang kinipong mga rocks or molten materials nga na-pile up sa mid-ocean ridge nga eventually na solidify, mag-behave po siya or ma-arrange po siya, ma-pattern po siya according sa polarity during that time. So for example, ang pinakalas ng polarity is normal polarity. Before normal polarity, nag-reverse polarity. Because our Earth, okay, nag-change yung polarity. So meaning, mahimo nato siyang ebidensya nga naga-spread ang seafloor because of the different anomalies or mga polarities sa atong seafloor. Okay? As it spread, kay di ba naga-change ang polarity sa atong magnetic field? Naga-change po ang arrangement sa mga bato, di ba nagapabulag siya ang sa mid-ocean ridge nga seafloor. So makaingon gyud tang ay tinuod jud ang seafloor spreading or tinuod ang continental drift because ang pattern sa mga bato or rocks nga na pile gikan sa mid-ocean ridge, gikan nga nag-solidify gikan sa magma, na-arrange siya. Okay, depende sa polarity ana nga panahon. Okay? So muna siya ang ebidensya sa magnetic anomalies or magnetic reversal. Okay? Like for example in this crest of Juan de Fuca, okay, makita nato ang pattern. Alright, so for example, we have the crest of Juan de Fuca. It's a ridge. Okay, so the plates involved here are divergent because nag-separate sila. Makita natin, okay, using the satellite, there is this magnetic reversal stripes which are symmetrical. Okay, and this is a very good evidence nga nag-spread ang atong seafloor.